1.4, trig functions at any angle. So not just on the unit circle angle. So when we're talking about this here, this is how we find our radius, which we have talked about. X squared plus y squared is the square root of that. Again, that's just bringing it back to a squared plus b squared equals c squared. And again, your c is always your radius. This still holds true for when you have a point, as long as you know your r value. Your sine is still your y value over your r, and so forth. But again, this is when we don't know the angle. So let's say if I'm given the point like this, find the terminal side of angle, find the three coefficients. So one thing I'm going to do is draw still my xy axis, -3, 4. That means that point would be someplace over here. So if I draw out that right triangle, my -3 is right here because I moved left 3 and went up 4. So you could do it still with these rules, or you could do it with the actually drawing out the triangle. So if I do this, my r is going to be the square root of -3 squared plus 4 squared, which would be equal to 5. That's a Pythagorean triple. And now I can use my 6 trig functions off of this, or I can use it with this. Either one will work. So if I have sine, that's my opposite, because here's my angle here is my opposite over my my hypotenuse, which would be 4 over the square root of 5. Again, this is where you have to rationalize that. So square root 5 over square root 5. So this is 4 square root 5 over 5. If you wanted to, you could do your y, which is my y value right here, divided by the not square root 5. I'm sorry. It was just 5. I don't know why I wrote square root over here. That's just 5. So just 4 over 5. You could use either property, either that triangle or these properties. So cosine adjacent over your hypotenuse, or again, cosine is your x over r, tangent is your y over x, or else you could also have it as your opposite over your adjacent, however your brain works. I like to always just do this based off of these 3 that we already have. So just the reciprocals of all of them, 5/3 and -3 over 4. So let's say now it's the same type of thing, except I have some restrictions here. Now, in this restrictions, depending on who you've had last year, I'm going to write this out. We have certain information about each quadrant. If you ever heard the saying of all sad turtles cry, that right there is telling you which trig function of the 3 main ones, so sine, cosine, tangent, is positive. So here, all 3 trig functions are positive. Here in my quadrant 2, just sine is positive. The other ones are negative, kind of like how we just saw that right here. Only sine was positive. Here, all sad turtles, this would just be tangent positive, and cry is cosine positive. Now, it's already giving us the tangent, and it's telling us that cosine is greater than 0. So because cosine is greater than 0, I'm working in the first or the fourth quadrant. However, because I know tangent is negative, that means it can't be in my first quadrant. So I know for sure that this is going to be in my fourth quadrant. So I'm going to draw this out here. Again, when I draw that right triangle, I'm going to draw it just like this. Here's my angle that I'm working with. And when I'm talking about this, tangent is my opposite. So here's my opposite over my adjacent. Now, when I'm looking at this, now I know where the negative should be. The negative should be with that opposite because my y value is going down, whereas my x value is going or adding. So again, same thing here. If I want to figure out my r value, I have x squared plus y squared, square root of that. If it's not a perfect square, I do not want to take this perfect square. So the square root of 41. So now I'm looking for sine. So my sine of my angle, this is now the square root of 41 is my opposite, so -5 over the square root of 41. You have to rationalize that. I do not want any roots on the bottom of the fraction. So now this becomes -5 square root 41 over 41. That's my sine. Secant, again, is the reciprocal of cosine. So cosine is my adjacent over my hypotenuse. So secant is my hypotenuse, or my r, again, if you wanted to bring it back up to here as a reference, your r over x, or my hypotenuse over my adjacent. So there you have it. So question number 3, I'm going to actually be focusing more on these properties because I'm asking for the cosine and tangent of these 4 quadrants. So if I'm looking at these, 0 would be right here. So that point of that angle is at 1, 0. Here is my pi over 2, so that's 0, 1. Here, that point is negative 1, 0. And here, that point is negative 1, 0. So now I'm going to use my x and y's more. So I'm looking at for the cosine and the tangent for each. Now again, the cosine is always going to be my x over r. In this case, my r is going to be 1 because these, when we're talking about the radians in a unit circle, my r is always equal to 1 because that's your unit circle, r is always equal to 1. So my x over r. So my x value here is 1. My radius is 1. So this is just equal to 1. So tangent of this is going to be my y over x. So y over x. So 0 over 1. So that's just going to be equal to 0. So again, that's at the 0 degree format. I want you to pause the video and try to do the rest of the 3 by yourself. So again, using those properties for cosine, x over r, x over r, x over r. But now when we have r, y over x, when we are dividing by 0, that's undefined. So at pi over 2 and 3 pi over 2, those are both undefined at my tangent. And at pi, or at 0 and 3 pi over and pi, or 2 pi, that's both of those going to be 0. So next we're talking about reference angles, and we kind of already talked about reference angles, but reference angles are the angle, if we want to draw a right triangle, that would be the same here. So it's kind of like helping us figure out these numbers so that we can draw a right triangle, even if our angle here is greater than 180. So when I'm looking at reference angles, there's 3 different ways that we might be doing this. If we have the angle in the second quadrant, if we want to figure out, we're always bringing it back to this 180 right here, our x-axis. If I want to draw this right triangle, I would figure out this angle. I would do 180, subtract my angle. So in the second quadrant, we do 180, subtract our angle, or pi, because remember, those are the same units. Pi and 180 units are the same. If it's in the third quadrant, now this is over 180. So this is where we're going to have to take our angle and subtract either pi or 180, depending on what our units are. And if it's in the fourth quadrant, we would want to make our right triangle here, so we'd want to figure out that angle. So in this case, we would want to take 360 or 2 pi, because those are equivalent, minus our angle. So when you're finding the reference angle, you can, if you want to, draw this so that you can kind of help you figure out what numbers you have going on here. So if we have 300, that would be in our fourth quadrant. This angle right here is 300. So my reference angle would be this angle. So now I see that with the reference angle, it creates a circle. So I'd do 360 minus my angle, and I would get my reference angle as 60 degrees. When I'm looking at 2.3 radians, again, I can set this up now with my radian measure. This is pi over 2, but because this is not in pi degrees or radians, then I can write that in as a decimal. So this is roughly about 1.5. This is at pi. Remember, that just would be at 1. This is at 3 pi over 2. And if I actually did that into my calculator, this would be 4.7. And this would be 2 pi, which would be roughly around 6. So this angle then at 2.3 is in between 1 and 4.7. So this right here is my angle. Okay. So now again, this is my radian measure, angle 2.3. So that's over 180. So if I want to figure out what just this angle is, now I see that it's overlapping. So that means I have to subtract off that 180. I'm in radians. So I'm going to have to take my 2.3 and subtract pi from it. And when I did that, I got a negative number. And that's how I realized that this is actually not in the third quadrant. I'm sorry, because this is 3.14 as a number. So my angle is right here. I'm deeply sorry about that. So this is my angle. So now, instead of subtracting, I want to figure out what this angle right here is, not this angle. And I would say that I would do pi subtract 2.3 to figure out my angle. And you would get that pi subtract 2.3, yes, I can erase, isn't that cool, is 0.842 radians. So that right there would be my reference angle. Last one I want you to try to pause and do by yourself. Remember, negative angles move counterclockwise, or you could add 360 to that to figure out its coterminal angle. There are two ways that you could go about doing this. If you did not change this into a positive number, and this is your angle right here, we're looking for this angle. So if I'm looking for that angle, again, this creates your 180. So I could do 180 subtract 135 because your reference angle should be a positive number. So if I did 180 subtract 135, I would get 45 degrees. Now let's say that you actually found this angle. By adding 200 or by adding 360, you could get that this is 225. So in this case, this angle right here is 225. So because of that overlap, then I would do 225 minus 180, and you would still get 45 degrees. That reference angle is going to be the same no matter which way you try to do it. So now if I evaluate, putting kind of two things together. So I have 4 pi over 3. So pi over 3 would be here, 2 pi over 3. This is 3 over 3. So now 4 pi over 3 is right here, this angle right here. The first thing I'm going to do is figure out that reference angle. So in this case, because of the overlap, I would take the 4 pi over 3, subtract pi from that, and I get that this is 1 pi over 3. So I know that this reference angle, pi over 3, is the same thing as 60 degrees. How do I know that? Because if this is 3, I know that that reference angle has to be a 6. So at the 60, I know that this right here is going to be across from the 60 is the square root 3. Because I'm moving down, it's negative. And right here, my adjacent would be 1. And because I'm moving to the left, it's negative. And my radius will be always 2. In this case, I'm looking for cosine. So cosine is my adjacent over my hypotenuse. So this is going to be negative 1/2. My adjacent over my hypotenuse. I want you to pause the video and try to do B and C by yourself. And for tangent negative 210, you should have got negative square root 3 over 3. And for cosecant, 3 pi over 4. And I do expect to see some triangle written. So if you're using your unit circle, you can do that to verify your answer. But I should see a unit circle drawn with your reference angle. So I know that you know where these numbers are coming from. Okay, 2 more examples left. Example 6. So now example 6 is starting to use our trig identities, which we have right over here. Now, if I give you sine, then I want you to find cosine first. So if we look at our trig identities, we have a trig identity right here of sine and cosine. So when I have that sine and cosine, I know that 1/3 squared, again, this is on your piece of paper, plus cosine squared, which we don't know what that is right now. I tend not to write the theta when I'm doing these problems, is equal to 1. Now I can solve this equation. So this becomes 1/9, because that squared is 1/9. And when I'm solving this, I want to subtract that 1/9 over. So cosine squared would be equal to 8/9. And when I take the square root of that, I need to simplify. So my cosine theta is going to be equal to the square root of 8 is the same thing as the square root of 4 times square root of 2. So this is where this 2 square root 2 comes from. And the square root of 9 is 3. So this right here is my final answer for cosine. Now, same thing, I have sine and I want to find tangent. I have sine, I want to find tangent. Well, we just found the cosine also. So we can use the cosine because we just found it. Now we can use this trig identity. So that's saying that tan of an angle is the same thing as sine, so 1/3, divided by cosine 2 square root 2 over 3. And when I divide by a fraction, that's the same thing as multiplying by. It's reciprocal. So I multiply by the reciprocal. These 3 cancel, leaving me with 1, 2 square root 2. And I don't want my answer to be like that. I need to rationalize that. So 2 square root 2 times. So on top, I'm going to have my square root 2. On bottom, this becomes 2. This right here also becomes 2, so this becomes over 4. So that right there is my final answer. And the last but not least, I'm using my calculator to solve these. Now this is where I have to know the difference between degrees and radians. If the degree symbol is not given, it is in radians. If the degree symbol is not given, it is in radians. So you should always check your mode. Right now I'm in degrees, so I'm good to go for this one. For cotangent, that's 1 divided by tangent. I would type in my 410. And In this case, I want you to round, I didn't say it, but to 4 decimals place. Let's go. Let's say you round to 3 because it didn't say. That would be okay. I'm not going to be super, super picky on that. And by this number, I mean that that's a 9. Again, erasable pens. Go for it. If there's no degree sign, why can't I see that? If there's no degree sign, then that means it's going to be radians. So I have to go back to mode. Can you see that? Radian measure. I go second mode to quit. So now I can go sign, -7, type that in, and I get negative 0.65. This actually would round. This 8 would round that 9 up. So that 9 actually rounds up to 70 if I ask for the 4th. And last but not least, secant. And again, I'm sorry if you can't see this. I don't know why the brightness is so low. So again, I'm in radian measure. So now I have secant. So that's 1 divided by cosine. And you should be typing pi in. Do not use 3.14 because pi goes on forever. So 1.064. And that 7 would round that up to 2. There you have it. Bing, bada, boom. And have a wonderful day.